Non-polar molecules are formed because of the covalent bond and usually they exist between the similar molecules. So according to the valence bond theory, covalent bonds are formed by overlapping of atomic orbitals of combining atoms. When two half-filled orbitals are overlapped sidewise, the pi bonds will be formed. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Chemical Bonding and Molecular Structure. Under that, we have discussed about the ionic bond and also we have discussed about the examples for the ionic bond and also we have learned about the factors which favors the ionic bond and we have discussed about the Born-Haber cycle to understand more about the formation of sodium chloride crystals. That is the ionic sodium chloride crystals will be deeply understood by Born-Haber cycle and also we have understood about the bond parameters. Today, let us move on to the next topic of this unit by understanding dipole moment and we are going to understand the polar and the non-polar molecule and we are going to understand VBT, that is valence bond theory. Later we are going to understand the types of overlapping due to the valence bond theory and lastly we are going to discuss with the differences between sigma bond and pi bond. Let's see what is a dipole moment. So, dipole moment which is nothing but a product of charge on the atom as well as the distance, the radius or you can say that the distances between the positive and the negative charges, that is known as dipole moment and it is obtained by a formula that is mu is equal to Q into R where Q represents the charge on the atom whereas the small r represents the differences, that is the distances between the charges. Okay, and remember further we can clearly understand that this dipole moment will be also expressed as d by units. This is a unit for the dipole moment and it has a constant value around 3.33564 into 10 to the power of minus 30. Okay, this is a constant value for the dipole moment and always remember it is a product of charge on the atom and the distances between the charges. Okay, and furthermore about this dipole moment we are going to understand by writing the polar and non-polar molecule. Let's see what are the non-polar molecules first. Okay, non-polar molecules are formed because of the covalent bond and usually they exist between the similar molecule. Okay, when covalent bonds are formed between two similar atoms by shared pair of electrons equally attracted by the two atoms and the bonds are formed are known as non-polar bonds and the molecules are known as non-polar molecule. Here I have an example of hydrogen. So in case of hydrogen molecule and oxygen molecule, we know that the oxygen which has what? Which has two oxygen atom and they have shared the 4 electron, thereby it forms what? Double bond. Similarly, in between the two hydrogen atom, it forms a single covalent bond by sharing of how many electron? 1 electron. Similarly, in case of nitrogen, you know, between the two nitrogen atom, there will be a triple bond and it will share 3 electrons to form a triple bond. This is how we can easily understand how non-polar bonds and non-polar molecules will be formed. Always remember, if I say it is non-polar molecule which is formed by a covalent bond by mutual sharing of its electron and usually they are similar types of atoms will be there. Example, you can remember with the hydrogen molecule, oxygen molecule or with the nitrogen molecule. Now let us see what are polar molecules. In case of polar molecules, there will be no symmetrical structures and it has a permanent dipole moment. Whereas non-polar molecules, usually their dipole moment will be 0. Okay. But in case of this polar molecules, it has a permanent dipole moment. Okay. So, example is water molecule. If you write a water molecule, we know that there are 2 hydrogen atoms which is followed by 1 oxygen atom will be there. Between these 2 OH bond, we know that it has a bond angle of 104.5 degree and it has a dipole moment around 1.86. This indicates that these polar bonds are formed by sharing of electrons, and remember here 2 dissimilar atoms are share its electron to form a polar bond, and such molecules are known as polar molecules. You can take one more example of BF3, that is boron fluoride. In case of boron fluoride, you can see that the dipole moment will be represented by arrow with this directions. Okay, this indicates that in BF3, the dipole moment will be 0. That is mainly because the boron and the fluoride bonds are oriented at an angle of 120 degree to one another, and 3 bond movements give rise to the net sum of 0. So, if you consider any 2-1 structure, you can clearly understand that their dipole moment will be cancelled with each other. Hence, they have a 0 dipole moment. Even though these 2 elements are dissimilar, they have a covalent bond between them, but their dipole moment will be 0. We can take one more example by considering ammonia or with NF3. Okay, both the molecules have a pyramidal shape with 1 lone pair of electron on nitrogen atom. Although fluorine is electronegative than nitrogen, hence the net dipole moment of ammonia is greater than that of the NF3. You can see that this is ammonia which is having 3 hydrogen atom with 1 nitrogen atom, and we know that this nitrogen atom always carries one lone pair of electron. Similarly, if you consider NF3, okay, this nitrogen atom which is also carrying 1 lone pair of electron, if you compare these 2 structure, it will be exhibits in a pyramidal shape, but if you compare the dipole moment, here the NF3 is much lower than that of the NH3 because of the more electronegative nature of the fluorine atom. So, hence these molecules which have a lower dipole moment than that of the ammonia. This is how, by comparing the polar molecules only, we can understand that how the dipole moment is also, it increases or decreases due to the presence of more electronegative element. Next is valence bond theory. So, for the examination point of view, this concept is very important, and this postulate will be always asked for 3 marks. Okay. What is this valence bond theory? What are the importance of valence bond theory? What are the types of overlapping? Let us understand now. Okay. So, according to the valence bond theory, covalent bonds are formed by overlapping of atomic orbitals of combining atoms. According to the valence bond theory, what does it say? The covalent bonds are always formed by what? Sharing of electron, mutual sharing of electron we can say. But here, according to the VBT, it says that covalent bonds are always formed by overlapping of combining atoms. Okay, let us see with their silent features. They are nothing but a postulates. Okay, covalent bonds are formed by overlapping of orbitals having 2 unpairs of electron with the opposite spin. So, what does the first postulate says that? It says that overlapping must be taking place with 2 unpaired electrons with the opposite spin. Then only the covalent bond will be formed. And the second postulate tells us that when overlapping between the orbital is greater, the covalent bond which is formed, that is always stronger. If two electrons are present in opposite spin, their overlapping will be effective. If overlapping are more effective or greater, obviously the bond which is formed, that will be stronger. When covalent bonds are formed, the energy of the molecule decreases and molecules are become more stable. It is very important. So once it forms the covalent bond, the actual energy in the molecules will be get decreases, but the entire molecules are become what? More stable. Why it has become more stable? Because it's mutually sharing its electron to attain what? Stable electronic configuration. That is why the molecules are become more stable. And the extent of overlapping will be always in this order. First will be the SS orbital overlapping, SP overlapping and PP overlapping. And overlapping along the sideways are always stronger than that of the overlapping on the opposite side. Or you can say that overlapping on the sideways, which is always lower than that of the overlapping on the axial sides. And we see that axial overlapping also has a sigma bond and sideways overlapping also as a pi bond. More about that sigma and pi bond we are going to understand in the next slide. Okay, these are the 5 important postulates of valence bond theory. Again, I am repeating, these postulates are very important for the examination point of view. Next, we will see the types of overlapping. So, already I have explained that if overlapping is taking place on the sideways, we say it is pi bond. If the overlapping which is taking place on the axial side, then we say it is sigma bond. Okay. So, the covalent bonds are classified into 2 types depending upon the types of overlapping. The first is sigma bond and next is pi bond. So, let us see what is a sigma bond first. When 2 half-filled orbitals are overlapped in the axis, sigma bonds will be formed. Always remember, when I talk about the sigma bond, this overlapping must be taking place in the axial direction. Such bonds are formed or known as sigma bond. Here I have an example. And before that, remember, this is also known as head overlapping or axial overlapping. This is formed with one of the following types of overlapping here. I'll take with the SS overlapping. So, what does SS overlapping indicates? SS overlapping which indicates that it is the overlapping between the 2 s orbitals. So, I'll take the example of hydrogen molecule. So, this is my hydrogen molecules which is formed from what? 2 hydrogen atom. Is it right? So, which is having how many electron? We know that each hydrogen atom have 1 electron in the s orbital. Is it right? It has 1 electron in the s orbital. When they overlap themselves, results in a formation of hydrogen molecule. Since here you can see that s and s orbitals are getting overlapped axially, they are said to be sigma bond. It is said to be sigma bond because these 2 orbitals, they are overlapped axially. And remember, and it is a SS type of overlapping. Now let us see the SP overlapping. Okay. So this is a type of overlap which occurs between the half-filled s orbital and of one atom and half-filled p orbitals of another atom. We know that the s orbitals which is always having a spherical shape. Similarly, the p orbitals which is having dumbbell shape, whereas d orbitals which is having what? Double dumbbell shape. Is it right? Whereas the shape of the f orbitals will be complex, as we have already understood. Now, if the overlapping which is taking place between the s and p, both will which consists of what? Half-filled atomic orbital, which results in a formation of sigma bond because those overlapping which is taking place axially. Such bonds are known as sigma sp bond because it is a s and p orbitals, they overlap themselves. Okay. Similarly, we can understand what is a pp overlapping also. That is, pp means p orbital overlapping. How does it takes place? This is a type of overlap which is taking place between the half-filled p orbitals with the another half-filled p orbitals. You can see that these two are the half-filled p orbitals. When they overlap themselves axially, again I am repeating the word axially, they results in the formation of sigma pp bond. This is how we can easily understand how does the sigma bonds will be formed by overlapping of half-filled atomic orbitals axially results in a formation of sigma bond. Okay. Next, let us see what are pi bonds. When two half-filled orbitals are overlapped sidewise, the pi bonds will be formed. Okay. Example is a formation of oxygen molecule. So, the electronic configuration of oxygen in the ground state is helium 2s2 and 2p2, and you can see that in the p orbital there are 4 electrons will be there, and I have split the p orbitals into 3 subatomic orbitals and I have written how many electrons are present in a p orbital, or you can write this structure also as 1s2, 2s2, 2p4. Is it right? And you can expect this p orbitals also as what? 3 subatomic orbitals, and we know that this is 2px, 2py, 2pz. How many electrons will be there in p? 4. 1, 2, 3 and remaining 4. And you can see that in 2py 1 electron will be there and 2pz 1 electron will be there. This is an actual ground state electronic configuration of oxygen. When half-filled 2py orbitals of two oxygen atoms, when they overlap with internuclear axis to form what? Sigma bond, and the remaining half-filled 2pz orbitals, they overlap laterally and it forms what? Pi bond, and the double bonds which exists between the two oxygen atom. You can see that there is a one unpaired electron which is present in oxygen atom, especially at py and at the 2py, which consists of what? One unpaired electron. Similarly, the 2pz and 2pz, which consists of what? One electron. This 2pz, they overlap themselves, they overlap laterally and results in a formation of what? Pi bond. And remaining this 2py and 2py of other oxygen atom, they overlap axially and results in a formation of what? Sigma bond. This is how in oxygen atom we can expect there is a formation of pi bond as well as a sigma bond. How does the pi bond will be formed here? Pi bonds are formed by overlapping of 2pz orbitals. They are overlapped laterally or sidewise to form what? Pi bond. Similarly, the 2py and 2py orbitals, they overlap themselves and results in a formation of what? Sigma bond. That is why when you are writing the two oxygen atom, we write double bond between them. One is sigma bond and one is pi bond. Now let us see what are the differences between sigma bond and pi bond. Just now we have learned that sigma bonds are formed by axial overlapping, whereas pi bonds are formed by what? Sideways or lateral overlapping. Okay, and always remember the sigma bonds are very much stronger when it is compared with the pi bond. Okay, so overlapping is quite effective and bonds are strong. Overlapping is less effective and comparatively this pi bonds are weaker as it is compared with the sigma bond. And s orbitals can take part in what? Sigma bond formation, whereas in the pi bond, never s block elements, or you can say that the s orbital will never involve in the pi bond formation. And only one lobe of the p orbitals are involved in the overlapping. Both the lobes of the p orbitals are involved in the overlapping of pi orbitals. And electron clouds of the molecular orbitals are symmetrical around the intermolecular axis, and electron clouds are known as unsymmetrical. Okay, and bonds are formed in the absence of the bond, and electron clouds are formed in the absence of bond also. This is very, very important. And free rotation of atoms around the pi bonds are formed, but the free rotations of atom around the pi bond, which is not possible. This is how we can easily understand the differences between the pi bond and sigma bond. Again, for the examination point of view, it will be asked for 2 marks, and again it is very, very important. Hope you all understood with the differences. Now let us see what are the limitations of valence bond theory. Valence bond theory is limited to the diatomic molecules only. So this valence bond approach, it tells us that the overlapping must be taking place between the 2 half-filled atomic orbitals. Is it right? It will be applicable only to the diatomic like hydrogen, H2, oxygen, O2 and nitrogen, N2. But for the triatomic molecules, it does not be explained. And it could not explain the structure and the bond angles of the molecule more than the 3 atoms. If more than 3 atoms will be there, it does not explain its structure along with the bond angle. So, example is, it could not explain the structure and the bond angle of water and ammonia. However, in order to explain the structure and the bond angles of the molecule, Linnaeus Pauling modified the valence bond theory by using what? Hybridization concept. So, Linnaeus Pauling was a scientist. He altered this VBT theory and he used the term known as, or he used the concept known as hybridization to explain the structure as well as their geometry. So, more about the hybridization we are going to understand in the next session. So, by this, I like to say that what are all the things which I covered in this session? Again, it is very important for the examination point of view. Have a look on it and try to work out. We'll meet you with the next session. Till that, take care, be safe. Thank you.